Okay, polymers and plastics. These are important modern materials. Poly is a prefix that means many. So polymer, many mers. I keep meaning to look up what a mer is, but I don't know. So a polymer is a long molecule composed of lots of monomers. There are a lot of natural polymers, starches, proteins. Your DNA is a polymer. And there are also lots of synthetic ones, all the plastics, PVC, plexiglass, nylon, styrofoam, lots and lots of different polymers. They tend to be very durable because these really long molecules, and they can be really, really long. They can actually be long enough that you can see them. They are going to have higher melting and boiling points because they have stronger intermolecular forces. They've got better surface area, and they can get really tangled with each other. In order to break or tear the polymer, you either have to break covalent bonds holding the individual molecules together, or you have to overcome the intermolecular forces, which are stronger than they are in smaller molecules. Polyethylene is a very simple type of synthetic polymer. So this is an ethylene molecule. It's also known as ethene. And so this is the monomer, and you connect a whole bunch of these into a long chain, and you have polyethylene. So these are going to react with each other. These have a double bond, and so we can break the pi bond here and get this carbon to bond instead to the next carbon atom, and we can end up with a chain like this of CH2. And so you get a really, really long strings of this.
So plastics are carbons?
A lot of plastics are hydrocarbons, yeah.
I was thinking plastics were silicates.
No. Silicates would be more the ceramics and glass.
Oh, okay.
Yeah.
That's why you get plastics from oil, right?
Yeah. So fossil fuels, petroleum products are used to create plastics because that's where you get the hydrocarbons. Yep. So this is an example of an addition polymer where you're just adding these together and you're not actually losing any atoms. There's different types of polyethylene. There's high density and low density, and they're going to have different characteristics. High density is going to have less branching, so longer strings that are not all branched and messy. Low density is a lot of branching, and so they're going to twist around on each other a lot. Then you can take your regular polyethylene and substitute things. So here you can use a chloroethene, so you've got a chlorine on here. And so now you're going to get a similar carbon chain here, but every other carbon is going to have a chlorine on it. It almost looks like a chain, a chain with little charms on it, like a bracelet. And another word for, well, there's all these weird names, but this is polyvinyl chloride, PVC. There are copolymers, where you have two different kinds of monomers that come together. The monomers are going to come together and make a dimer, which is two mers, and then those dimers will polymerize. So here we have an example of, I believe this is making nylon. We have hexamethylene diamine and adipic acid, and those two monomers can react together to form a dimer. Now this is called a condensation polymer because we've got this atom, several atoms here that get removed. So essentially it's losing a water molecule as those react together. And then you can react those dimers. So here's a table from your book just showing some different types of plastics and what they're used for. These are addition polymers, the polyethylene. You can do it with propylene, styrene. Here's the polyvinyl chloride. Then you have condensation polymers where you've got, when the monomers or dimers come together, they eliminate something.
So like when plastics burn and they have that different colored flame, what's causing that?
That's a good question. What causes the...
Green and red, bright red.
What would cause a different colored flame when plastics burn?
Different sodiums, right? Different salts.
Well, yeah, different salts. There may be some metals present in the polymer, but I really don't know. I do know that you don't want to be throwing plastics on a campfire and be breathing the fumes that come off of it, because it can make lots of different things and they can be pretty bad for you because they're not going to burn efficiently like they should.